Hi guys, welcome to Delores Studios. This is another episode of Android Programming. We'll be looking at the Android Room Persistent Library. In the first tutorial about this, we had the create and the read implemented. In this video, we'll be talking about the update and the delete implementation of how to interact with the Room Persistent Library, that's the Android architecture, which will be pointing out the executor instead of doing the doing background over and over. We'll be using the executor class in Android, which we could actually look at the documentation on how this flow. We'll be implementing that for the background threads, for Dix.io, and also for network calls. So I will implore you to look at that. We'll get to look at the developer page of the executor. We'll get to look at that later, right in the tutorial. Back to Android Studio, we have the implementation. Now we're going to implement the swipe to delete, where we're going to actually swipe a list item to get that deleted, and it's not just going to be deleted or deleted from the Recyclerview. It's actually going to take effect from the SQLite database that you're going to actually delete from the database while swiping. We're going to update a record on click of an item on the Recyclerview. It should take you back to the edit page, or the page where you actually enter those values, and you get the room to edit any of the field and also commit changes to the SQLite database. So we're actually going to be talking about that to implementation in this video. So a quick brush to the tree of the video. I have the first part, which I've showed earlier. This is going to be the concluding part. We have the database package, where you have the entity, the data abstract objects class, and the room database itself. In the entity, which it's actually going to depict the columns that you'll be needing for your database, we have that right there. We have the primary key, which is auto generation, which is true. The columns first name, last name, title, department, and if you notice, we have two constructors. The first constructor without an ID, while the second constructor has an ID. The ignore here will make the system identify when you need this. So it's actually going to ignore this and use the second constructor. And the setter and getter, we should be familiar with that by now. We have the data abstract object, which is actually going to interact with the database, where you get to instantiate or declare any of your queries. You have that the select from table, order by the first name, which is actually going to be handled by the live data. You have that set up as the first query here. You have the insert based on the object of a class. You have that as well. We have the delete from the table, and which is deleting all from the table. Now we're including the updates, which you update the tags based on the object of the entity. You could see that, which is word, and you need to put an annotation of on conflict. So it's actually going to replace on conflict strategy. So it's actually going to make each of the fields unique. That's the essence of that. It's not going to keep replicating what it has. We have the delete tags based on the word object, or we have that as a query. You could also point that to the object, and you have the load. This time you want to fetch the record by its ID. So look at the query. Select all, which is the star, from word table, where the ID is what they're passing. This is the variable. This is what you need right there, which is the ID, which is actually going to be unique to each of the fields in the SQLite database. We have the room database still right insert, where you could reuse this boilerplate. It's actually a chunk where you could actually use to connect to your database and get that instantiated. Cool. We have no touch with that, but we putting you directly straight to the tax model. We actually use our own kind of tax model. You could still use the word view model, which you have, and where you point to the live data to keep fetching for data on the fly. You know, any change on the database will be reflected in the live data. That's the set of live data. And you have the call to the constructor of the load a tax by that ID, or load an item by its ID, using the tax data abstract object, which you're actually going to retrieve from the constructor of the database based on the ID. You could see that the tax ID, and you have the getter for the tax variable to get all the tags of the live data. Cool. So you have that setup. Let's get to look at the tax view model factory. This extends the view model provider, calling the new instance factory, where you also need an object of the database and the integer, that's the ID itself that you're actually pointing at. So that's where you get to call the constructor, where you pass the two parameters, the database object and the integer, the ID, which is unique, which is a primary key of each of your entity. And you have that initialized right there in the constructor. And you have the view model, where you get to extend that using the generic class, and you could instantiate the tax view model and passing those values as well. So we'll be using the factory as well. Let's get to look at the app executors. This is where this is where I want you to actually look at very vividly. If you are actually querying the database on the main thread, there's going to be a lot of performance issues. There could be a crash in your application. There could be a lot of there could be a lot of errors that might occur, or memory leak that might occur in the process of querying the database on the main thread. So that's why you should do that in the background thread. And doing that in the background thread, you have different aspects. You could use a handler, you could use the async tags, you could use some other background threading implementation. But this could be messy when you have to do this over and over again. You need to call, you need to initiate a query in 5 different places. We have to start running an handler in 5 different places, or you start to run the async tags in 5 different places. So that's where the app executors come in. Let's get to look at the documentation. Maybe it's gonna be open for us. Cool. We have that set up. An object that executes submitted the runnable tags. This interface provides a way of decoupling tags submission from the mechanics of how each task will run, including the details of thread use, the scheduling. An executor is normally used instead of explicitly creating threads. For example, rather than invoking the instantiation of the new thread, which is the new runnable, for each of a task, you might use an executor. So this is a reusable chunk that could be used, that could replace the runnable, the async tags. You know what I mean? So let's get back to the code. Now we're going to have the app executors, which listen to disk IO, which also run on the main thread, which can also listen to network IO. So cool. We're passing all those 3 parameters and initializing them right there in the constructor. So depends on the kind of network call you need, or the kind of interaction, or the kind of background process, or the background implementation you want to do in your application. So you have the setup, you have a static which you could call an instance to initialize that, and now we create 3 threads to actually handle this, where you get to instantiate right there with a thread integer, and you call on the main thread executor, because it's definitely when you're running on the background thread, you will need a result, the main thread, which you actually run on the UI thread. You have that set up, and this actually handled by an handler with a looper to actually get that done for you. So this could be reused anytime you need to call a background call, or you need to do something that would need a background thread for. So cool. With that, we've had that set up. We'll get to use that right there in the course of the application. In the main activity now we're going to change the way that you're going to be interacting with the database. Now we have that set up. You can see that I commented some aspects, which is actually coming from the first code, and now we're trying to modify things and clean up things, making it more readable. We have the Recyclerview, which is set up. We should now set up a Recyclerview and the adapter to take in a list values. That's a list, or an array list, to actually to display that in the Recyclerview. Now let's get to see the item touch helper. This is always useful when you want to swipe. You need a swipe effect on the Recyclerview. Once you swipe, you can swipe left, you can swipe right. So at that point in time, you need an action. You need to delete that record from the SQLite database, and at the same time, you need to notify data changed on the Recyclerview, so that the Recyclerview could close up and get that done. So you instantiate the item touch helper, where you get the simple callback on move and on swiped. On swiped, that's when you're actually swiping left or right on the view order. That's where I'm holding on to. So you need to implement the swipe to delete. Now I get to see how we're going to do this. We call the app executors. get the instance. Now the disk IO, if it's a network call, you call the network. So we are actually interacting with the disk IO since we are having the SQLite running right there in your device. And you instantiate the new runnable, and you have a run to override. At this point in time, that's where you get to take the action. Now we get a position whereby you get the view that get the adaptive position. That's the position where the view there is, which is going to be an integer ID. Cool. And now you get to call the get tax on the adapter to get the kind of tax it is. You pass that to the list of tax, and at this point in time, you have your database object right there, which you could interact with the data abstract object, and in turn you get to point at the tax that they execute. What are you executing? Is it the delete? Are you trying to read? Are you trying to update? You could understand what I'm trying to say here. Now you need to delete, and you need to pass an ID, which is going to be the tax, which you will have right there as the object of the list of the entity. And now you call the position to get the ID, the exact ID of what you're swiping at. So that's the ID you need to actually get your delete done. So cool. So you have that set up. Now you need to attach that to the Recyclerview, so that's actually going to listen that on the Recyclerview. We still have the floating action button set up, which you get to create a new word activity or a new field to actually get that done, and that's still cool. Now let's get to see the way we abstract away the setup view model from the onCreate method. Now in this, this is where you get to initialize the view model. That's the provider. You call the class in question, and you set the adapter to what you get from the live data on the tax entry school. You can see it right there. So let's get to see the full on change. So this will continue to change if there is a new data, if there's a fetch new data. So you set that to the adapter, so it's keep listening to any changes from the live data. So cool. That's just it. And set that to adapter for display. You have that set up. The aspect we get to look. Let's get to look at the item click listener. We created an item click listener on the adapter. That's on the items of each of the Recyclerview item. So that a click on that takes you where? It takes you back to the new word activity. That's where you get to create the fields in the first place. So you could do what? You could be able to update those fields. So that's just what that's going to take us. And now you're going to pass in an extra. And what extra are you passing? You're passing the extra tax ID. That's a constant, and you're passing the ID itself. What is the ID of the item that you're clicking on? Are you clicking on ID 1? Are you clicking on ID 2? That's just the identifier. You need to. That's just what you need. You don't need to start passing all those fields that are attached to the item. Just an ID is okay. You'll get to see how we're going to decouple that in the next activity. Cool. This is the activity that you'll be pointing at, and this activity takes two functions. The first function is to update. The second function is to create. So we've actually discussed about the creation. Now let's focus on the update. Now, how are you going to know that what you click is to update? You have an intent that you're expecting, and you need to test or check if the intent has an extra. That's just what you get to know if this is a new record or you're trying to update a record. So when you're updating, once you have that extra, the extra tax ID, you could be able to identify that this is an update, and from there you get to run that. And what you're going to be doing from the fields already, you have that. So let's see what we're going to be doing. We'll populate the UI by getting the int extra from the constant that we have, which is a string constant, and we're going to have that as the tax ID. Now let's see what we're going to do. We're going to remove a login and call the load tax by its ID, which we have the implementation in the data abstract object, and we're going to declare the tax view model factory. This is where we need a factory here, which is actually going to using the database object and the tax ID itself. So now we point at the factory and instantiate that and pass in those two parameters, which are generic, which are we've actually declared. Discussed that right there before this. And after that, you declare a variable and initialize it by calling for that use, which the factory was created. We should understand that, which is what we've done right here. Now what we're going to do, we need to further extract the values, because we need to extract the name, title, and so on. So what we're going to do, you observe the live data object in the view model, which is actually going to use when you're removing the observer. So what you're going to do, you call the observer to the instantiate that, and unchanged, you pass the view model, which you've actually add an object of that view model from the implementation of the view model providers. You get the tags, and you remove the observer once you've gotten the tags. After that, you populate the UI, which is a method that is actually going to extract the values from the object, the tags entry. So what's the populate UI going to do? That's it over there. It's actually going to test if the tax is not null. If it's not, just return. You don't need to go further since it's not. If it's not null, move further to decouple the object. Now you're going to call the tax, get the first name, just like we have the poetry already. Tax, get the last, get the title, get the department. Set that to the different edit text that you have set up already. The employee, the first name, the last name, the title, and the department. So you could in turn make a change and still trigger the save button to save that to the SQLite database. Now if you're saving, you will be using the app executors, get instance, dix.io, you execute that on the runnable, a new runnable, which will provide the run method, and after that you call the database object pointing at the data abstract objects. After that, pointing at the method right in there to do the tags and passing the tags as the parameter to actually get it done to insert into a new text. And if you're updating, you can see an else statement is going to set the ID to the tax ID, and in turn you still call the data object, the data abstract objects pointing at that, and now you're pointing at the update tax still based on the tax object. You can see how we're manipulating objects, we're passing less values, and we're getting this done quicker, faster, and efficiently using the Android architecture. You could see we're just interacting with objects and objects and objects, not with keys, values, key values, key values we've always known to do. So with objects you could manipulate things. That's why I call it the data abstract object, and that's the essence of the room database, which you're going to be interacting with objects, and you get that done in due time, easily and efficiently. I'll be actually be showing the video or the screencast rather to implement this and to let you see what we've done, and I'll be committing the source code to the GitHub repo, which is actually going to come in a new branch. I'll employ you to lay hands on this. We have a lot to talk about, and I'll be rolling out some videos when it comes to Kotlin. We should start to look at Kotlin as well. Let's embrace Kotlin and let's start to do some implementation in Kotlin, majorly in Kotlin. KTX that actually came out that has so many implementation with the Android support library. So we have that all in stock, and we'll be rolling that as time goes on. So I'll employ you to leave any comments below if you have any of your query. I'll be there to answer them. If there are things that could easily get them solved for you, I will be there to also solve it. And if you actually need any project to be done, or you need some of your work to get done, I'll be there to help you out. I'll be there to actually get it done for you, and I'll employ you to also stick by within the Studios. Don't go anywhere. So thank you very much for hanging out with me throughout this video, and have a pleasant time. Bye bye for now.